Hello, everybody. So this is one of two videos I'm making for Lab 15. And so in this video, we're going to do Lab 15, and I'm going to do it on a Mac. In the other video, I'm going to do Lab 15, and we're going to do it on a PC, just to see a slight difference in how you might do it. Um, all right, with that said, let's just go ahead and get started. I will say that if you go to the home page, which is loading really slow for some reason. If you go to the home page and you look down here, you'll see that like lecture one here for week 15 has file input and output. That's really where a lot of the instructions come from. And so I'm not going to cover the stuff in this video in as much detail as we do in this previous video. So we'll go to lab 15 and we'll read it. Let's see what it says. All right, create a new Java project. So basically what we're doing is we have two assignments here. We're going to read a file and we're going to write a file. So I don't know which one's first. So lab exercises, create a new Java project and add this stuff. Cool. So in Eclipse, close this. We'll go File, New Java Project, Lab 15. Um, it won't let me do that. Why not? Oh, a project with this name already exists. Okay. So Lab 15 V2. Cool. All right. So I've got a project here. We'll go ahead and create a new class. I'll just call that Lab 15 and check the box for public static void main as per usual. I'm going to move the console down here. And all right. So add these imports at the top. So these are the imports that you need if you're going to output to a file. So it looks like this is going to be probably the more challenging of the two exercises first, where we're writing a file. Um, on the line where your main method goes, we need to add this, throws IO exception, and that goes right here between the parentheses and the curly braces. And there we go. So you need that. Add lines like the ones below to prepare an output file to be written. This is, I'm going to change it a little bit. I'll copy paste this, but then I'll change it a little bit. So file output stream, file stream. You don't need equals null there. Null is just kind of reinforcing the idea that we're not like putting anything in those variables yet. They're just existing. So you need a file stream and you need a print writer to write to a file. So the file stream is a new file output stream, and then this is a file that you want to write to. And then you do outfs equals new print writer file stream. So the name of this variable here, file stream, matches the one that we did previously. Cool. Get out of my way, autocomplete. What's next? Now we should be able to write to our file. And this is just an example here. As it says, these are just examples. And what we're trying to write is something like this. Now, this is very similar to what we did in the Lab 15 for writing files. So we're going to try to write a file that looks like this. It's going to have three columns. So a column for X, a column for Y equals sine X, and a column for Z equals cosine X. And we're just going to be putting in a bunch of numbers. Okay, so to write the top line into our file, we can now use like print, printf, print line, etc. And so you use them, but they're part now of this outfs print writer object that we created. So it'd be outfs dot print line, for example. And in quotes, I can just put this, which I just literally copy pasted from right here. So like I know that this is going to be correct or not correct, but it's going to line up like this if I copy paste to this. Okay. Um, Whoop, don't want to save that. So there we go. And at the end of this whole thing, at some point, I'm going to close my file like so. And if I run this right now, it runs. We don't see anything in the console because the only writing we did was to the file. So what file? Well, the name is my out file. And where is it? Well, it's in your project folder. So this is the Mac video. So if I were to click on my project and I go to properties and I click on the little icon here next to the location, it'll open a folder near my project. So remember, my project is called Lab 15v2. So if I click the button, we're in a folder and Lab 15v2 is somewhere. I can click on it and lo and behold, it says my out file right there. I can open that up and I can see that it's got some text in it, right? That's the text that I wrote. So I need to be able to get to this folder where that file is. And kind of the reason we're doing writing before reading in this assignment is because if you write to a file, we'll know for sure when we find the right folder because we found this file, right? That's the file we were looking for, and we found it in the project folder. Cool. So having done that, go back here. And the rest of this is, as it says, we're going to fill out this table here with numbers. And it says the numbers should all line up vertically. Use printf with appropriate settings to make that happen. We should have 32 lines in your text file at the end, 31 rows of numbers. And if you look 2 bullet points ahead, it says you do not need to store the numbers in an array. You could, but you could use a for loop. And we can make the for loop go from negative 1.5 to positive 1.5. And, we're counting up from negative 1.5 up to 1.5 by, it looks like by 0.1. And so we did this in the other video, like I said, so we're not going to explain the concept here, but we can create let's say a double variable or two double variables for X and Y maybe. And then in here, we can say for X equals negative 1.5. That's where we want to start. X less than positive 1.5, less than or equal. That's where we want to end. Then we can't do X plus plus because that would add 1. We want to add 0.1. So it would be X plus equals 0.1, like so. And then here we can do whatever we want. So specifically, we're going to need an X, Y, and a Z, aren't we? So as it says here, Y is supposed to be sine X and Z is going to be cosine X. So I should go back up here and add a Z. So we have X, Y, Z. And then Y is supposed to be sine X, which is math dot sine X. Z is supposed to be cosine X. So math dot cosine X. And now we have the X, the Y, and the Z, and we want to print them to our file. So we'll do it just like we did the top line, but instead of using print line, we'll use printf because printf will allow us to control the number of decimal places and things like that. So the way that looks is in parentheses, we put how we want our numbers to print. Looking at the example, we see that the first one should be 1 decimal place, and then 4 decimal places, and then 4 decimal places if we're copying this format. So that would look like percent dot 1f for the 1 decimal place for 1, skip a couple places, percent dot 4f for the 4 decimal places, skip a couple more places, and percent dot 4f again for another 4 decimal places. And then after the quotes, you would do comma X, comma Y, comma Z, and it'll fill in those numbers into those spots. Also, we need a new line. So back in the quotes here, put \n. Cool. Now I put outfs here, but outfs dot printf. Sorry. And there we go. So that should basically do it. It's complaining about this. Why? OutFS is never closed. Yeah, it is. Oh well. I don't know what it is saying so, but whatever. Run this again. And if we go to, we can open the folder where we saved this before, and we can look at it and we can see it's basically okay. The problem with this is really just that they're not quite lining up here. And that's because of these negative values are kind of messing with things. So the way to make them line up when there's negative signs is to reserve a certain number of spaces. So like the negative 1.5s is, just make this all bigger. The negative 1.5s is taking up one, two, three, four spaces. But down here, when you're doing like 1.4, 1.5, it's one, two, three spaces. So these take up three spaces and these take up four spaces, and that's why they don't line up. So you can fix that by in here instead of doing just dot one, you could do, for example, 4.1, and that would reserve four spaces and round to one decimal place. And so right there, I can run this again. We'll have to close the text editor, wherever that is. Closed itself? I don't know. Open that up. And you can see that those line up a little better now. But then you see you have the same issue over here. So how many spaces do we need here? One, two, three, four, five, six, seven. So we can make sure that we reserve seven spaces. Where am I? How do I? Here we are. Nope. Here we are. We can reserve seven spaces for each of these. That's probably going to make it too wide, so I'm going to take out a couple of spaces here. And we'll run this and see what it looks like. Maybe I shouldn't have done that. We'll find out. Where's the, um, oh, here. All right. Cool. Everything's lined up except that I guess I should not have removed those spaces. So we'll come back here, add two back in, run this again. Look at, oop, yeah, look at it again. Seems okay. Actually, maybe we can go even, this can go over one more space or something. So maybe we add one more space there and one more space there. And that looks perfect. Cool. Now, one last thing I see is that this actually did not make it all the way to 1.5. It stopped at 1.4. That's because what are they called? Doubles are not precise on a computer. They're only to a certain number of decimal places. So what could happen here is we're going until x is, or while x is less than or equal to 1.5. And so the one that should be equal to 1.5 is probably just a little bit bigger. And so it gets cut off. So to fix this, you could add like an extra like, oh, not that. You could add an extra like 0.1 on the end of there. Just make that slightly bigger than 1.5. And then when you run this and you look again, you'll see that it does make it to positive 1.5 now. Cool. So we just calculated the sine and the cosine of a bunch of different values, and we just threw them into a table. And that's our text file. All right. So that takes care of all this. Then it says add the file bicubic text. It says to your Replit project or your Eclipse folder. So the reason we wrote the file first was because I can download this file. Hopefully it works. Did it? It is not working. Open up. Okay, finally. I just probably downloaded it like 5 times here. Um, oh geez. All right. I'm going to do something here. I'm going to click view as student. I want to make sure that that file's downloadable for you guys. I'm realizing that the reason this is slow is because I'm on a VPN. Um, so oopsies. But I'll click Lab 15 again. I'm going to try to download this again. Let's see. Okay, so that is accessible to everybody. So I have this folder file in my folder called bicubic.txt, and that's what we need to, we're going to print it out. Okay, so we're going to print this out. We can do this in the same project here. And so we need to know where that is. Now, it does suggest here to like put this into your Eclipse folder. And then you can see here to open it up this way with file input stream by cubic.txt, and that's it. But what we could do is, first of all, add these imports to the top. Let's take it in order. So we'll go up here, add these imports. So scanner for reading stuff, text, and then file input stream for reading files. And you can just go below here. Now we're going to read a file. How do we do it? Well, we need this stuff. So we create a file input stream. We create a scanner. Um, this is for, what is this for? What's it say? Using a read the entire file line by line and output the text to the console. Um, we do not actually need this file num here. So like this line is not going to be used. Um, but it doesn't hurt to be there. Just we're not going to use it. And we're going to try to open this file by cubic.txt. Now, if you put by cubic.txt in this folder, my out file, like next to my out file, then this will work. Okay. If you don't do that, if you just keep it in your downloads folder on a Mac, I can click downloads, sort this by date added. If I can find it, that's the wrong way. There we go. If I right click on this and I hold option on a Mac, I can do copy by cubic text as path name. And I can put that in here, save it. And that's the full path to the file. And then I don't have to worry about what folder it's in as long as it actually, that file exists. Cool. What are we doing? Using an appropriate loop, read the entire file line by line. So we learned in the previous video that you use this kind of loop that says while nfs dot has next. nfs is your scanner. So like nfs equals new scanner. That's going to allow us to read the file until we run out of things in the file to read. And so what we could do is we could read a line. What does the bicubic text look like, by the way? Oops. Open that up. And you can see that it's just a bunch of lines of text. These are math formulas that are for a video game project thing. These are the coefficients needed to do bicubic image scaling. But it doesn't matter what they are, they're just text. So we need a string. So up here I should have a string. I can call it whatever I want. I'll call it line. And then in here, we'll make the line equal to, and we'll read one line from our file, which is going to be nfs dot next line. And after we read that line, we're supposed to print it to the console. So we'll do a regular old system.out.println, and we'll print the line. And when we're all done with this, nfs dot close. It close the file. Save that, run it, and if we did this right, the console should get the output of our file. Okay, so it wants to read my downloads folder, allow it. Okay. There we go. So this is the text file that I had. And this is just kind of generic, like this code right here is just a generic, we're reading a file and printing it to the console code. And that is the entire lab. So that's the lab. I will record this again, but I'll record it in Windows instead of Mac OS. All right, so that's going to be it for this video. So I'm going to stop it here and I will talk to you guys later. Where's the stop?